Okay, you might not have had time to get done with all these, but let's go through and see what you've got done. First thing I'm going to do is make a little more room here quick. Oops. Move these down the page a bit. There. So now, for this first one here, we didn't do any examples yesterday with negatives in them, but it really doesn't affect the calculation much. What I'm going to do is this. I'm going to pull out the numbers. So I can cross cancel. We did one example yesterday like this. So both the 14 and 56 divide by what number? 7. Good. Negative 14 divided by 7 is negative 2. 56 divided by 7 is 8. Now they will still divide by 2. So I got negative 1 and 4. 33 and 55 both divide by 11. 55 divided by 11 is 5. 33 divided by 11 is 3. So we've got negative 1 times 5 is negative 5. 3 times 4 is 12. So in our answer, we've got a negative 5 on top and a 12 on bottom. Next we have the variables. I can do it right in the problem, or I can pull them out. I've got a y to the third on top and a y to the fifth on bottom.
Y to the second on bottom?
Y to the second on bottom. The larger one is on bottom, so that ends up on bottom, and then 5 minus 3 is 2. So I've got negative 5 over 12y squared. Now remember, we mentioned at one point those negatives can go anywhere. I could leave it like that as negative 5 over 12y squared, or I could put the negative out in front. That means the same thing. So either one of those would be acceptable. Just making...
I don't do the translation, so I'm trying
Okay. And if you don't do the cross canceling, it just ends up being 770 over...
Yeah, 1848,
Yeah.
and then trying to break it down.
Then having to reduce them by... It reduces by 154, yeah.
And it's really frustrating.
Yeah. I mean, if you do it that way and trying to reduce it, it will reduce down. You just got to be patient and keep picking away at it. Okay, so now number 2 here, division. First thing I have to do, the first fraction, of course, doesn't change, but we turn it into multiplication, and we do the reciprocal of the one that we're dividing by. Remember, the division operates on the number that comes after it, the fraction that comes after it. So now we can cross cancel here. I'm going to do it right within here now. 24 and 32 can both be divided by 6 won't go into 32. 8, there we go. 24 divided by 8 is 3. 32 divided by 8 is 4. 35 and 45 both divide by 5. 35 divided by 5? 7. 45 divided by 5? 9. So now for the numbers, we got 3 times 9 is 27. 7 times 4 is 28. For the x's, I've got x to the fifth on top and x on bottom. X to the fourth on top, yes. The larger power is on top, and we subtract 5 minus 1 is 4. Now for me, this method is easier, pulling out the numbers and doing them, and then pulling out the variables and doing them. This is definitely shorter, doing everything all at once, but it's really easy to lose track of the variables when you do it that way. At least for me it is. And then, of course, the third way, like you said, is just multiply it out and get the big number and then try to reduce it.
It takes forever.
It does take a while to reduce it. You're right. Like here, what do you get? Like 10,000 or 1,080 or something like that when you multiply.
Over 1120.
Yeah. So yeah, it's a little bit of work reducing them.
Yep. And then I start really getting frustrated.
Yeah, it's going to be about a 6 or 7 step reduction there, but if you keep dividing by 2s and 3s and.
Right.
Okay, so now 3 and 4 here. I have 3 over 8b plus 5 over 6b squared. I need to find that least common denominator, least common multiple. Well, I'm going to start out with the numbers. For 8 and 6, what is the least common denominator? 24 is correct. Now, if you haven't noticed yet, there is a pattern for the variables. For b and b squared, it always ends up being the higher power. So the larger power is b squared. So now I have to look at, oops, get back here. What do I multiply 8 by to make 24? 3. What do I multiply b by to make b squared?
2.
B, right? B times b makes b squared. So 8b has to be multiplied by 3b in order to get 24b squared. So 3b, or 3 on top has to be multiplied by 3b as well. What's that give me on top?
9b.
9b, yes. 3 times 3b is 9b. Down here, what does 6 have to multiply by to make 24? 4. B squared doesn't have to do anything because it's already b squared, right? So I just have to multiply the 5 up here by 4. 5 times 4 is 20. And now we are adding here 9b plus 20 is 9b plus 20 over my 24b squared.
That's it. Add the 9b and the 20 because they don't have the same.
They don't have the same name. So it's just 9b plus 20 is just 9b plus 20. Over here, 7 over 12xy minus 3 over 8x squared. Common denominator, again, we're going to go with numbers first. 8 and 12, what's my common denominator? 24 is the smallest one. Now let's look at each variable separately. For x, what is my largest power? X squared. So x to the second, or x squared. For y, well, just y is the largest power, so I got to have a y there. So 24x squared y is my least common denominator. So again, you just do the numbers separately, you get the least common denominator for the numbers, then the variables, you just take the larger power. So now, what do I multiply 12 by to make 24? 2. Do I have to do anything to the x? Yeah, x times x to make x squared, so times an x. Do I have to do anything to the y? No. It's y already, and it's just going to stay y. So I have to multiply the 7 by 2x as well. What do I get? 7 times 2 is 14, and then the x. On bottom, what do I multiply the 8 by to make 24? 3. What do I do to the x squared? Nothing, but I do need the y. You are correct, 3y. So I multiply the numerator by 3y. What is 3 times 3y? 3 times 3 makes 9, right? So 9y. And now we subtract 14x minus 9y. Is 14x minus 9y over the 24x squared y. Anybody have all 4 of those first 4 right? Show of hands. Okay, you only had the first couple done? Okay. Okay, now for these two, we didn't specifically do problems like this yesterday, but we did the skills separately. First, in this one, is there anything I can reduce here inside the parentheses?
No.
No, there's not. So the next step, like we saw with our numerical fraction, when we raise it to a power, if the fraction is raised to the power, that's just taking the numerator to that power and the denominator to that power. So now in the numerator, 7x to the fourth to the power of 3. What is 7 to the power of 3? 343. Very good. X to the fourth to the power of 3. X to the 12. Very good. When we have an exponent raised to another power, we multiply the powers. So now on bottom, 8y squared to the power of 3. What's 8 to the power of 3? 512. Y squared to the power of 3? I heard somebody say there, y to the 6th, right? And that's it. All done. Now number 6 has an extra step or two in it. First, we need to see, can we reduce this fraction in here? And yes, we can. 12 over 20, those both divide by what number? 4. Very good. What's 12 divided by 4?
3.
3. 20 divided by 4? 5. Good. So we know that as we reduce that, we're going to have 3 on the numerator and 5 in the denominator. What's going to happen with x? Top or bottom? Top and power of 2. Very good. The larger power was on top, and 5 minus 3 makes 2. What's going to happen with y?
It goes on the bottom.
Bottom and power of
1.
1 or just y, right? This is all still to the power of 4. So now we're going to split that up. The numerator to the power of 4 and the denominator to the power of 4. What is 3 to the power of 4?
81.
81. X squared to the power of 4.
625.
X to the 8th.
Oh.
2 times 4 is 8, right? On bottom, 5 to the power of 4 is 625. How about y to the power of 4? Y to the 4. Yeah, you think of that as y to the 1, and 1 times 4 is 4, right? So there it is. Any questions so far?
Can we do multiplying a whole number in a fraction?
Sure.
I had problems with that on the homework. That was
Let's just do just numerical without variables.
yeah.
Let's try this one, 12 times 3/8.
Okay.
I'll give you a second to try that one. Now, if we were doing this one by hand, the key would be to make this 12 over 1. And now it's a fraction, right?
Okay.
And now we could multiply it out and get 36 over 8 and work from there. Or we could cross cancel. We could reduce. 12 and 8 both divide by 4. Give me 3 and 2. So 3 times 3 is 9, and 1 times 2 is 2. 9 divided by 2 is 4 and 1/2. 2 goes into 9 4 times with 1 left over. Any others that you want to see? Now, I realize the homework from yesterday, we covered a lot of stuff in class yesterday. So, the homework is technically set to be due at noon today. If you're not done at that time, that's fine. Keep working on it. Because I'd prefer you have that done before you do the quiz.
That's what I was trying to do.
So make sure you get that done today. I will, like I said, when I transfer the grades on Thursday, I'll be transferring those grades from my math lab into Blackboard, and I will remove any late penalties on the homework then. Going through the homework, like I said, there was a lot of stuff. It was all the same stuff, but seen in a lot of different ways yesterday. So is there anything on the homework that you want to look at? I know I had a couple of...
200 questions. I gave up.
What's that?
I said I had all of the homework that was due yesterday to do. That was 70, plus the quiz, plus the homework due today. I give up.
It was just too much for you in one day. That was...
I agree.
Yeah, if you had to do two homework...
4 hours, and I'm still have 30 more to do.
Okay.
I give up.
It was pretty.
Yeah, that was the malfunction over the weekend. Not being able to do the homework over the weekend really was kind of a killer on this one, because it was two of our biggest homework assignments got stacked together. So, stay with. Did you get the quiz done?
Yeah, but I missed over half of them, and I just gave up.
Okay. What I'm going to do is I will actually reset the quiz for the whole class so that you guys can redo that. Today or tomorrow. Since tomorrow's our day off, I'll give you it till the end of the day tomorrow so you got time to catch up. Like I said, on the homework, feel free to go back on the homework and work on them. And the quiz that's due tonight, I will push that back till the end of the day tomorrow as well. Just like I said, it was the malfunction in my math lab, not being able to access it over the weekend was the worst possible time, because literally it was our two largest homework assignments got stacked. There's 270 question homework assignments that got stacked on top of each other because of that, and that just was not good. I was kind of mad at them.
4 hours of doing it in tears. I just give up.
Yeah,
I was
and
going to start throwing stuff.
I'm the recommendation for this class now. I will say this, the college standard, now this is a remedial class, so it's a little bit looser, but the college standard is every hour in class, 2 hours outside of class. So it's not unexpected for a 2.5 hour class to have 4 or 5 hours of outside work a day, but I'm not going to ask that in the summer. I mean, that's because of the summer class. In the regular semester, you would have 4 hours of class during the whole week, which would mean 8 hours during the spread out over a whole week, not 4 hours stacked in a single day. Yes.
Oh, because I've got 18 hours for my first semester.
Yeah. Yeah. Well, you're different. You're in a vocational class. So in a vocational class, it's a little bit lighter. They figure you have some time in class to work. So yeah, they figure in a vocational class it's about 1-to-1.
Okay.
But if you're in an associate degree program, they do figure 2 hours for every hour of class. So just so you guys are preparing for fall, that is an expectation in a lot of your classes. I don't expect that here because this is the class where we're just getting you broke in, and being a summer class, the hours would stack up extreme. So I'm not expecting that out of you here. If in any given day you get more than 3 hours in on homework, feel free to quit and tell me about it, and we'll adjust it for you. I would not want anybody to put more than 3 hours a day in on this stuff, just because your mind isn't going to be any good at it anyway. So I appreciate that you put in the 4 hours on it. That's going above and beyond, and I totally understand that you were frustrated and ready to give up at that point.
I was in tears.
Yeah, and I'm sorry about that. That
On top of my other class homework.
yeah.
Did
But like-
anybody have problems with the website?
On the homework.
Yeah,
Sorry.
yeah. Go ahead.
Number 32 was find the area of a triangle whose base is 18 meters and the height is 27 meters. I
Okay.
had somebody help me with this. But we just kind of cut the triangle in half and flipped it over and made a rectangle, and I don't know.
And then divide by 2.
Okay. Well,
Shocking.
there are two ways to approach that one. And I'm going to let you give me the numbers. What were your numbers?
18 meters for the base and 27 meters for the height.
Okay. So I'm obviously not drawing the scale here, but that's okay. There are two ways to do that. Like you said, you could actually cut it in half. You could cut this in half and flip it up like that to make a rectangle. So it'd be 9 by 27. The other way is you could look at it as a rectangle that is 27 by 18, and you only have half of it. Yes. So for a triangle, the area actually is 1/2 of the base times the height, or base times height divided by 2. So what you did there was exactly correct. You did the 27 times 18, then divided by 2. Or you just did 27 times 9, which is the same thing. Any other questions off the homework?
Number 43.
43. A payroll clerk told Lisa Arias. Now, I've got 4/17. Did you have a different fraction?
3/17.
3/17. Okay. Of her weekly income is withheld for her taxes. What amount is withheld each week if she earns $1,530 a week? What was your weekly amount?
1,496.
1,496. So what we are really doing there is just taking 3/17 times 1,496. So we have to do 3/17, 1,496 over 7, or over 1, I should say. Now I should check to see if 17 is prime. The only thing it divides by is 1 and 17. So I'm just going to check to make sure 1496 does not divide by 17. And it does. So 1496 divided by 17 is 88. So what that means is I can cross cancel here. 17 divided by 17 is 1. 1496 divided by 17 is 88. So I have 3 times 88, which is 264. And 1 times 1 is 1. So that is $264 is the amount withheld. Okay. But that's the biggest thing there is looking at that. The only possible thing that could cross cancel is that 17. So you have to check to see if the 1496 divides by 17. If you didn't see that, that one would be a tough one to do. Any others?
Can we go over the
Go ahead.
least common multiples?
Least common multiples, yes.
Yeah, I
Thank you.
was having a hell of a time with that.
Yeah, I'm trying to figure out how to enter it. I was like, it is the right one, but the computer wouldn't let me because I didn't enter it right. And
Oh, sure.
I'm getting confused about, after you do the tree, the factoring tree, and figure out all the numbers,
Yep.
I can't seem to figure out, like, say there's two twos in one and 3 2s in the other. I was confused as to how many 2s to add.
Okay.
2 or the 3. I kept coming up with the wrong number.
Okay, so remember, least common multiple and least common denominator are kind of the same thing. And what you're finding is something larger than either number. Greatest common factor, you'd be looking at finding something smaller than either number. But the least common multiple is you're trying to take both numbers and go into this least common multiple or least common denominator. So let's say we have 18 and 20. And I want to find the least common multiple. Well, you do your factor tree for 18, you're going to get 2 times 3 times 3. Do the factor tree for 20, you get 2 times 2 times 5. What do they have in common? They have a 2 in common. So I'm circling the 2 only because that one's already good. That one's already covered. But we need everything in common. So the top number needs another 2 and a 5. Now the top number has everything that the bottom number has. The bottom number needs the 2 3s. So on top here, this is 18 times 2 times 5 is 10, so it'd be 180. On bottom, this part is 20. 3 times 3 is 9, so 20 times 9 is also 180. So 180 is your least common multiple or least common denominator. If we had, let's see here. Let's say we're going to do 30 x squared y and 45 x y to the 4th. Throwing in the variables always makes it more fun, right? So we factor that out. It's 2 times 3 times 5, and then x times y. The 45 is 3 times 3 times 5 times x, and then y. So what do we have in common? We have a 3, we have a 5, we have an x, and we have a y. Well, what's missing? On top here, we've got a 2 and an x. So the bottom needs to have a 2 and an x. On bottom, we've got 3 and 3 y's. So the top needs a 3 and 3 y's. So 2 times 3 times 5 is 30, times 3 is 90. We've still got the x squared. Then we've got y, and then y is y to the 4th. On bottom, just to double check. Now, at this point, we could be done. That is our least common multiple. But I always like to double check just to make sure I get the same thing on the other number. So 3, 3, and 5 make 45. Times 2 is 90. I've got x times another x is x squared. Then I have y is y to the 4th. And remember, we had mentioned earlier today that the shortcut is you can find the least common multiple for the numbers. So I could have just done the 2, 3, 5 and the 3, 3, 5. And said, hey, I need a 3 up here and a 2 down here, which gives me the 90. And then I can just take the larger power of the variables. For x, well, I've got x squared and x, so that means it's going to be x squared. For y, I've got y and y to the 4th, so the larger power is y to the 4th, which is 90y to the 4th. Or 90x squared y to the 4th, I should say. I'm going to have you guys try one. So we're going to do 60, x to the 5th, y to the 9th. And let's see here. Let's do 90, x to the 7th, y to the 5th. Find the least common multiple for those. Okay, so now I am going to ignore the variables for right now. I'm just going to factor 60, which is 2 times 2 times 3 times 5. Now I'm going to pause. Does anybody have questions on how I came up with those numbers there?
It takes me forever to get them. You gotta sit there and pump away in my head.
Well, you've got start out with 60, right? Now remember, I always do, my sequence is 10, 5, 2, 3. So I look at that. That ends in a 0, so I know it divides by 10. 60 divided by 10 is 6. That's what's left over. Those are not prime, so I can split them down. 10 is just 2 times 5. Those are both prime. 6 is 2 times 3. Those are both prime. So 2, 2, 3, 5. Do the same with 90. It ends in a 0, so I know it divides by 10. What would be left over?
9.
9. 10 splits into 2 and 5, both prime. 9 splits into 3 and 3. Those are both prime. So 90 is 2 times 3 times 3 times 5. So now looking at it, they both have a 2, both have a 3, they both have a 5. Now I'm just looking through it. What's not circled? There's a 2 here, so I'm going to put a 2 on bottom. There's a 3 here, so I'm going to put a 3 on top. So this is saying 60 times 3, which is 180. This is 90 times 2, which is also 180. So the number is 180. For the variable, remember for least common multiple, we take the larger power. So 5 and 7, that's going to be x to the 7. And then y to the 9th is the larger power. 180, x to the 7, y to the 9th. Anybody want to see one more example? Want to do one more? Might as well? Okay. So we have 28 x to the 3rd, y to the 5th, z. And we are going to have 42 x to the 5th, y squared, x to the 5th, y squared. That's where we're going to stop. I'll give you a minute to try that one. Okay, let's see what we got. Again, I'm going to ignore the variables. 28 factors into 2 times 2 times 7, right? 42 factors into 732, 237, yep. I always go smallest to largest because then it's easier for me to come pick out the common ones. So I've got a 2 and I've got a 7. So again, there's a 2 that isn't circled here, so I'm going to put a 2 down here. There's a 3 here that isn't circled, so I'm going to put a 3 up here. So this is 28 times 3 is 84. This is 42 times 2, which is also 84. If those numbers don't come out the same, you did something wrong. So it's time to start over. So we've got 84, and then what? Yep. Y to the 5th. And then just z. Even though there isn't a z here, there's a z up here, and the larger power is z to the 1, or just z. Does that help?
Yes.
Okay, good.
Thank you.
You bet.
Those get really good.
Anything else off the homework? Okay, just so you know, as we were doing those 2 example problems, I did go in. The quiz that was due yesterday and the quiz that is due today, I pushed both of those back so that you have until the end of the day tomorrow to finish those up. There's also a quiz on there that is listed to be due on Thursday afternoon after the test. That is an optional quiz for extra credit.
I need it.
Well, because of the summer shortened up, it takes out a bunch of the quizzes. So I put that one in there just so it gives you a chance of, the test is everything from the last week all bunched together. That quiz is just the stuff from the last day. It's a chance to earn 10 extra points just to help you out. What happens?
It says,
Oops, go ahead.
oh, no, go ahead, sorry.
What happens at the end of the semester, what I do is oh, sorry, go ahead. Go ahead.
It's okay, Pete, this ITV thing, because it's such a pause. On mine, it says test 1 in class from June 20th is past due.
Yeah, that's just because it wasn't taken in my math lab.
Oh, okay, good.
It should be in the grade book in Blackboard, though.
Okay, good.
Yep.
It is.
Okay.
What number is the quiz for extra credit?
The quiz for extra credit is quiz 7.
Okay, I don't see it.
Yeah.
It won't appear until Thursday.
Oh, okay.
And what I did is I actually pushed that one back while I was in here. I pushed that back till Friday night. Just because I figured there's a good chance you guys are going to walk out of here on Thursday after the test and not want to see math again for a day or so. This is the part of the summer where the summer format really does start to drain you. Because like I said, if this were during the semester, we'd be coming up halfway, almost to the end of week 5 and starting week 6 already. So we've crammed this into 2.5 weeks. So this is that part where it feels like a grind.
Yeah.
And we get through here, starting the middle of next week, things slow down a little bit again. We have another test that comes up, I think, on the 10th of July or 10th or 11th of July. And then we have like 2 weeks before our last test.
And we definitely, school's closed on the 4th, right?
Yeah, school is, the building is closed on the 4th. You couldn't even get in the building if you want to. So.
Do we have homework for that day?
No, there's no extra, no new homework for that.
Okay.
There'll be homework from the 3rd.
Okay.
Yes, kind of a bad schedule this year with the 4th being on a Tuesday. It's nice that the 4th is on a Monday, then you just get a long weekend. But
Right.
yeah, we come back, we have one class on Monday, and then we have one class on Thursday, and that's our week. It would be better if the 4th was on Thursday, then you'd have Wednesday through
Oh,
Sunday off, for me at least. Now, if you're taking online classes, because most of our summer classes are online, a lot of the online classes do ignore holidays. So if you're taking online classes, be very careful, because they may have stuff due. A lot of them have stuff due on Sundays and Saturdays and holidays. So. If you normally have a Tuesday assignments due, there might still be a Tuesday assignment due for the 4th, just so you know. Okay, so we've been working with fractions for a day or so now. Now I want to make that next step up to what we had looked at with the mixed numbers. So far, all we've really done is convert with the mixed numbers from mixed numbers to improper fractions and back again. And we noted that when we were dealing with algebraic fractions, there is no such thing as a mixed number, because we don't know whether it's improper or not, because we don't know the value of those variables, of those letters. So the good news is, when we're dealing with mixed numbers, we can't use variables. There won't be any variables in these. These will be all real numbers, numerical numbers. So we're going to start out at the very beginning with addition. Something like 2 1/2 plus 5 3/8. Now, just like I did yesterday, I'm going to set up my addition vertically. Just because that's how I think. Now, some people do not rewrite the whole number when they get the common denominator. I always do, because it keeps me from forgetting about it. I have found through the years some people find the common denominator, then they combine the fractions, and they forget about that whole number portion up there. So rewriting it just keeps me from losing it. Now I have the 2 and the 8. What is the common or least common denominator going to be for them? 8. Yes. 2 goes into 8, so I don't need to change the 8 at all. So this bottom is still going to be 5 3/8. That will not change. What's this number up here going to become?
4.
4. Very good. 2 times 4 to make 8, so 1 times 4 to make 4. Now, when we added whole numbers, we started on the right and we worked our way back to the left. You'll look at the way I set up these mixed numbers. That fraction is sitting at the end almost like it's just the last digit of the number. And in fact, that's exactly what it is. The fraction is just the last digit at the end of the number. So when I go to add, I'm going to start on the right and work my way back to the left. And I'm going to do the fraction first because that is my last digit. 4/8 plus 3/8 makes 7/8. 2 plus 5 is 7. So that is 7 7/8. So I'm going to have 38 1/4 plus 17 1/6. So first thing I'm going to do is I have to find my common denominator again. What's it going to be? 12. Perfect. What's going to go in here?
3.
3, good. 4 times 3, so 1 times 3. What's going to go here? 2, very good. 6 times 2 to make 12, so 1 times, 6 times 2 to make 12, so 1 times 2 is 2. And now again, I start on the right and work my way back to the left. So 3/12 plus 2/12 is? 5/12. 8 and 7? 15. So 5, carry the 1. 1, 3, and 1? 5. So 55 and 5/12. Now you'll notice there I had to do some carrying. I carried that 1 up. Well, it's not always just within the whole numbers. We can run into that with our fraction as well. We might have 6 3/8. I'm just going to write them vertically to save time. 6 3/8 plus 2 5/6. So the whole numbers, of course, don't change. What is my common denominator for 8 and 6? 24 is correct. What's going to go here?
18.
Well, 3 times 8 is 24, so 3 times 3 is 9. What's going to go here? 20, very good. 6 times 4 makes 24, so 5 times 4 is 20. So now we go ahead and add 9 24ths and 20 24ths. 29 24ths. Does anybody see a problem there? It's improper. It's exactly it. It's improper. That can be reduced to one whole object with how many pieces left over? 5 24ths left over. So just like with whole numbers, we're going to keep a portion of it. The fraction portion stays there in the fraction digit. That's the 5 24ths. And we carry the 1. So 1, 6, and 2 makes
9.
9. So 9 and 5 24ths. Very good. So I might have 46 2/3 plus 27 3/4. I'm going to have you try that one in your notes, and we'll talk about it in just a second. Okay, let's see how you're doing so far. First, we need common denominator, which will be 12. What goes up here?
8.
8. Very good. 3 times 4 to make 12. 2 times 4 makes 8. What goes here? 9. Good. 4 times 3 to make 12. 3 times 3 is 9. So we go ahead and add. 8 twelfths and 9 twelfths makes
17
17 twelfths, which is 1 and 5 twelfths. Very good. So we are going to keep the 5 twelfths and carry the 1. 1 and 6 is 7, plus 7 is 14. So keep the 4 and carry the 1. 1 and 4 is 5. plus 2 is 7. 74 and 5/12. Any questions? Okay, well, subtraction is pretty much the same thing, only subtracting, obviously. So we're going to start out with those vertical as well. So let's do 7 2/3 minus 4 3/5. So again, we need common denominator. What's it going to be?
15.
15. Very good. What's going to go up here? 10. Good. 3 times 5, so 2 times 5. What goes up here? 9, right? 5 times 3, so 3 times 3 is 9. So now when we subtract, again we start at the right and we work back to the left. We do the last digit first. So 10/15 minus 9/15 is 1/15. Very good. 7 minus 4 is 3. Well, that's not so bad. But of course, you guys probably know me well enough by now to know it gets worse. We can run into something like 1 1/4 minus 2 5/6. Oops. Don't want a denominator in there yet. What's our common denominator going to be here? 12. Okay, what's this going to be up here?
3.
3. Good. And down here? 10. Now again, we're going to start on the right and work our way back to the left. The only thing is here, 3/12 minus 10/12 isn't going to work, is it? Just like with whole numbers, we're going to borrow. We're going to borrow from the 8, and this is going to become 7. So what we borrowed is one whole object. How many pieces are in that one whole object? The denominator tells us there are 12 pieces in it. So we have to take the 3 pieces we have and add 12 to them. There's 15/12. So when we borrow with fractions, we are always adding the denominator to our current numerator to get the new fraction after we borrow. Because it's one whole object and the denominator tells us how many pieces are in that one object. So now it's 15 minus 10 is 5/12. 7 minus 2 is 5. So 5 and 5/12. Let's do another one. Let's do 42 2/3 minus 28 and let's do 11/12. What's our common denominator going to be? 12. Very good. So what's this going to become? 8. Very good. 3 times 4, so 2 times 4 is 8. What's this going to be? Trick question. It just stays 11. Yes. But we do come to subtract here. 8 minus 11 isn't going to work. So what do we have to do? Borrow from the 2 makes that a 1. What do we put on the 8? Add 12. Very good. Add our denominator. 8 plus 12 is 20. 12s. And now 20 minus 11? 9/12. Now before I move on, has anybody seen anything fishy there? Very good. 9/12 can be reduced by 3 to make 3/4. So I'm going to go ahead and reduce it. That's 3/4. So now here I've got 1 minus 8, so I'm going to borrow from the 4 to make it a 3. This is now 11. 11 minus 8 is 3, and 3 minus 2? 1. So 13 and 3/4. I'm going to have you try one in your notes. (23 1/4) minus 17 3/5. Give that one a shot in your notes, and we'll talk about it in just a minute. Before we get too far, is my computer screen still showing at your sites? I had a flicker here, and I had to turn it back on.
No, it's showing us.
It's showing? Anybody not seeing it? Okay. So what's our common denominator going to be? It shows for you? Good.
No, we can't see it here in Ashland.
You can't see it in Ashland? Okay, let me try it again here. I'll unsend it. And then we'll send it again. How about now? No?
No.
Okay, so that's the problem, is there's something there. I'm going to pause here, and then I'm going to... So we'll finish this example here. What did we have for our common denominators?
20.
20, good. What's going to go up here?
5.
5, and down here?
12.
12. So we go to subtract. 5 minus 12, of course, can't be done, so we are going to borrow from the 3. This is a 2, and what do we do here? Add the 20, so it's 25 20ths. And then?
Subtract 12 from 25.
25 minus 12 is 13 20ths. And then?
You can't subtract 7 from 2, so you gotta borrow.
So borrow from the 2, so that's a 12.
5.
So 12 minus 7 is 5. And the 1 minus 1 is nothing, so it's 5 and 13 20ths. Any questions there? Okay. Well, then it's time to move on to multiplication of mixed numbers. Of course, one thing makes sense. It's time to move on to something that doesn't, right? So we might have something like 3 1/4 times 7 3/5. Multiplying mixed numbers is an extremely difficult task. In fact, I bet if you went to the nearest university and found 10 math majors and asked them how to multiply mixed numbers, I would be shocked if even one of them could do it correctly. So we avoid doing it. And the way we avoid doing it is by converting them into... Somebody whispered it there. Improper
fractions.
There we go. Improper fractions. So this is still going to be fourths, and this is going to be fifths. What's this going to become up here?
3 times 4 is 13.
There we go. 3 times 4 is 12, plus the 1 is 13. What's this one going to become?
3 is 38.
Good. 7 times 5 is 35, plus 3 is 38. So that's 38 fifths. Now we can cross-cancel here. We can reduce. 4 and 38 both divide by 2. 4 divided by 2 is 2. 38 divided by 2 is 19. Now we can go ahead and multiply. 13 times 19 is 247. 2 times 5 is 10. Now, many of you can probably do this in your head, but I'm going to write it out. 247 divided by 10. 10 goes into 24 twice. That's 4 left over. Bring down the 7. 10 goes into 47 4 times. That's 40 with 7 left over. So that's 24 and 7/10. Is our answer. Now, just out of curiosity, I'm going to show you how we would do this with mixed numbers. You don't have to write this down because I'm never going to ask you to do this. You guys could not do enough to make me angry to force you to do this on a test. But now remember, when we did like 24 times 13, we did 3 times 4 and 3 times 2, right? We had to multiply every digit. Well, the same thing happens here. We not only have to do the 3/5 times the 1/4, but we're going to have to do 3/5 times the 3. So we'll start out with 3/5 times the 1/4. What's that going to give us? 3/20. Good. 3/5 times 3. Well, how do we multiply a fraction by a whole number?
3/1.
Make it 3/1. Very good. So that's 9/5, or 1 4/5. Then we've got 7 times 1/4. So again, 7/1 times 1/4 is 7/4, or 1 3/4. Then we've got 7 times 3, which is just 21. Well, now in this whole mess, we have to find common denominators to combine those. It's going to stay 20. So this is still 3/20. This will be 1 and 16/20. This will be 1 and
15.
15/20. There we go. And this is just 21 yet. So we have 3 and 16 is 19, 34/20, which is 17/10, right? Both divide by 2, which is 1 7/10. So I will keep the 7/10. Carry the 1. 1, 2, 3, 4, and 2. 24 7/10. I get the same answer. It's a lot more work. I'm going to stick with the improper fractions myself. It's funny because a lot of people didn't even realize that you can actually multiply out the improper fractions. So, or sorry, the mixed numbers, not the improper fractions. So for this class, we are going to stick to converting them to improper fractions. So let's do another example of that. Let's say we have 7 1/3 times 5 2/5. Tell me what to do. When we multiply, do we need a common denominator? No.
No. It's 7 times 3 plus 1.
Okay, perfect. We're making improper fractions. So 7 times 3 is 21, plus 1 is 22. And then?
5 times 5 plus 2.
Perfect. 5 times 5 is 25, plus 2 is 27. Now, if you look very closely, what you'll notice that we can do here?
You can get rid of the 3 and the 27.
3 and 27 both divide by 3, so we can reduce it. 3 divided by 3? 1. 27 divided by 3? 9. Very good. 22 times 9 is 198. 1 times 5 is 5. So then what?
You can't divide.
Well, we can do the division and remainder to get the mixed number, right? 5 does not go into 1. It goes into 15 or to 19 3 times. So that's 15 with 4 left over. Bring down the 8. 5 goes into 49 9 times. That's 40. 5 goes into 48 9 times. Sorry, my tongue is all twisted today. So that's 45 with 3 left over. So it is 39 3/5. Well, since I can't seem to talk, we're going to let you guys try one on your own. 2 5/6 times. Oh, let's do 4 3/8. So let's see how you're doing so far. What's this first improper fraction going to be?
17 over 16.
17 over
6.
6. What's the second one going to be? 35 over 8. Yep. And of course, you multiply 17 times 35 is 595. 6 times 8 is 48. So now it's a matter of reducing. Bless you. Bless you again. 595 divided by 48. 48 goes into 59 once. There's 11 left over. Bring down the 5. 48 goes into 115 twice. That would be 96. With 19 left over. So there's 12 and 19 48s. Is that what you came up with? Perfect. Let's look at division. When we divide mixed numbers, remember when we did fractions, I showed you some weird stuff, but when it came down to it, 3/4 divided by 1/5, all we did was we changed it into multiplication by the reciprocal. So that was 15 over 4, or 3 3/4. Now, first of all, you might wonder, how can we take 3/4, divide it by 1/5, two things that are smaller than 1, and get something bigger than 1? I thought when you divided, things got smaller. Well, remember, we talked about when we were doing whole numbers on that first day, division is subtraction, repeated subtraction. This is asking, how many times can I take 1/5 away from 3/4? Well, 1/5 is smaller than 3/4, so I can take it out several times. I take it out 3 times, and there's still some left over, is what that's telling me. So, when we have mixed numbers, 5 2/3 divided by 2 1/8. Since we are going to turn it into multiplication, it makes sense that we do the same thing that we did with multiplication, which is turn it into an improper fraction. So 5 2/3 becomes 17/3. There you go. 5 times 3 is 15, plus 2 is 17. And then this one's going to become 17/8. Very good. Can I cross cancel there now?
Well, you have to flip the 17 and the 8.
Yeah, right now I couldn't. There's nothing that cancels, but I couldn't anyway because it's division. So yes, we do have to make it into multiplication yet. So the first fraction never changes. The division acts on the second fraction. So this becomes times 8 over 17. Now we can cross cancel because it's now multiplication. What can we divide out?
17.
Yeah, 17 and 17. 17 divided by 17 is 1 for both of them. So now we have 1 times 8 is 8. 3 times 1 is 3. Which is 2 2/3. So division really isn't that tricky. It's just a matter of remembering to take that reciprocal. Now, before I cut off this recording and start a new one for the second half of class, I do want to show you. Remember that fateful ABC key on your calculator. If I wanted to enter this original problem into my calculator, it would be 5 ABC 2 ABC 3. That's 5 2/3. Then divided by 2 ABC 1 ABC 8. Hit equals. It spits out the 2 2/3. So the calculator is, I mean, it's nice to be able to do it by hand, but the calculator is there to catch you to double check. Okay, I am going to end this recording and start a new one for